Let's suppose that we want to test a claim about two unknown population means. Call that mu1 and mu2. Now there are three things that can happen. It's either going to be that mu1 is equal to mu2, or mu1 will be less than mu2, or it could be that mu1 is greater than mu2. If mu1 is equal to mu2, when I subtract mu2 from both sides of the equation, we'd get mu1 minus mu2, and that would have to be equal to 0. In the second situation, if mu1 is less than mu2, when I subtract mu2 over, we should have that mu1 minus mu2 will be less than 0. And in the third scenario, if we subtract mu2 from both sides, we'll have that mu1 minus mu2 should be greater than 0. That is, that it will be positive. And you can ask, well, why would we do these things? But what we're looking for here when we form this mu1 minus mu2 is that we have formed a single new parameter. That parameter is just the difference of those two. And we can estimate that population parameter by the point estimates from the sample x bar 1 minus x bar 2. So when we are looking, we're trying to find the sampling distribution for the difference of sample means, that is, the random variable is x bar 1 minus x bar 2, we need to have independent samples, and then we can use the 2SampZTest, provided we know sigma. So we're making a few assumptions though, because we're going to use the z-test. This needs to be normally distributed. So we need to assume that we have independent random samples. To use the z-test, sigma 1 and sigma 2 must be known. And then one of the two or both of the following conditions should be met. We need the sample sizes to be large and greater than or 30, or we need that the samples will come from populations that are normally distributed. We'll need to form a test statistic to perform the test. We'll look at the difference in the sample means. This is the observed values. And then we'll subtract off the difference in the population means. This is what we expect to happen. And of course, then we divide by the standard error. So the difference of population means then will be, if we've met all the conditions, that will be normally distributed, that has a mean that's mu1 minus mu2, and a standard of deviation that's given to the standard error. So the hypothesis of the test will use the difference of the population parameters, okay? So if we want to say that mu1 is equal to mu2, then the null hypothesis will contain the equality. We'll subtract over mu2, and the null hypothesis should say that the difference is equal to 0. The alternative hypothesis will take the opposing viewpoint, so it will say that the difference is not equal to 0. And then we'll just go through the rest. If we want to say that mu1 is less than mu2, then the difference of those should be less than 0, but for the null hypothesis, we need to have equality, so we'll say less than or equal to 0. Then the alternative hypothesis takes the opposing viewpoint, so it will say that the difference is positive, that is, that it's greater than 0. And similarly for the third case, if we say that mu1 is greater than mu2, then the difference mu1 minus mu2 should have the equality and be greater than or equal to 0, and the alternative hypothesis will say the opposing viewpoint and say that it is less than 0. The calculator function that we'll use to perform the test, you can find it under Stats and then Tests, and then go to the 2SampZTest. When we're calculating the confidence interval always says that you take your population parameter that you're looking for, in this case mu1 minus mu2, and that should go in between the point estimate minus the error and the point estimate plus the error, where our error is calculated down here. So I really could have rewritten this equation in the longer form, just substituting in E there and there. So if you have to calculate it by hand, that's the formula you will use. But luckily, our calculator will do this for us. The calculator function is found stats, test, and then you'll be looking for the 2SampleZ interval.